Yeah, starting off our list today with Exoplanet K2-18b, which just so happens to have an abundance of life-supporting molecules, meaning that it could very well have an abundance of life. In September of 2023, the James Webb Space Telescope, a highly advanced piece of equipment designed to conduct infrared observational astronomy using highly sensitive instruments that produce high-resolution images, discovered a large amount of methane and carbon dioxide in the atmosphere of the exoplanet. Located just 120 light-years away from Earth, because of this, K2-18b, which is larger than Earth but still smaller than other giant planets in our solar system, is speculated to be a Hycean world, an exoplanet that features a liquid water ocean hidden beneath a hydrogen-rich atmosphere. If 1 light-year is 37,200 human years and the exoplanet is, in fact, inhabited by extraterrestrial life forms, it is entirely possible that in 4,464 years, or sooner, if they started their journey before today, we could see aliens arriving on Earth from the newly discovered K2-18b. Something really cool about the James Webb Telescope is that it's sending us images from way back in time, and a recent observation may be making scientists rethink everything they thought about the very beginning of time as we know it. The James Webb Telescope recently found one of the key ingredients for life, carbon, from just 350 million years after the Big Bang, which happened around 13.8 billion years ago. The James Webb uses its near-infrared camera to capture images of distant objects, but because light from these objects takes a long time to reach us, we see them as they were in the past. This means the telescope is showing us what the universe looked like billions of years ago. Webb's latest discovery is a massive cloud of carbon in a far-off galaxy, and this is a very interesting finding because astronomers previously thought that carbon only started forming about 1 billion years after the Big Bang. So now, they're thinking it might have actually formed much earlier. Since carbon is fundamental to life, this also means that life might have formed much earlier in the universe than we previously thought, other life that could be somewhere out there as we speak. Next up, we have lookalikes, Milky Way lookalikes. The Milky Way being our home galaxy, and the lookalikes being massive, mysterious galaxies almost as big as our own, spread out across the universe. They are unexpected, confusing, and for now, inexplicable. These galaxies are far too big, with red stars far too old for them to be new, which frustrates scientists because the images are in direct conflict with all existing ideas of how the universe might have looked in its early years. It is likely, based on the images, that these galaxies formed just 500 to 700 million years after the Big Bang that created our universe. Not only that, but the images captured on the James Webb Telescope don't match any earlier observations made by the Hubble Space Telescope, Webb's less powerful predecessor. In response to the conundrum, Assistant Professor of Astronomy and Astrophysics at Penn State, Joel Leha, had this to say: "We had specific expectations for the type of galaxies that live in the early universe. They are young and small. This discovery is astounding because we're finding galaxy candidates that would have been as massive as our own galaxy when the universe was just 3% of its current age. While we don't know much about our universe, at least we know that we don't know much." Next, we have some James Webb Telescope news released just in the past week. It observed a massive asteroid collision. Asteroid and collision, never two words you want to hear in the same sentence. Luckily, this happened very far away from us, but it does go to show just how dangerous asteroids are. The space accident happened in the Beta Pictoris system, which is 63 light-years from Earth. The system is about 20 million years old, also very young compared to our 4.5 billion-year-old solar system. Christine Chen, an astronomer at Johns Hopkins University, shared the findings at a recent astronomy conference. She explained that Beta Pictoris is still forming, with 2 known gas giant planets, Beta Pictoris b and c, and lots of dust and debris, meaning that there's ongoing planet formation. Chen first observed Beta Pictoris with the Spitzer Space Telescope in 2004 and 2005, but fast forward to 2023, and the James Webb Space Telescope gives us a much clearer view. Comparing the old and the new data, Chen and her team realized that 2 major dust clouds they'd seen earlier had now disappeared, so they figured there was a massive collision between two giant asteroids. This crash would have pulverized the asteroids into that dust that was observed earlier, and it's now dissipated. And the really scary part? They estimated that the dust cloud created by the collision was about 100,000 times the mass of the asteroid that wiped out the dinosaurs. Next up, we have supermassive black holes. Any sentence involving both the words supermassive and black holes is sure to make the hairs on the back of your neck stand up, or possibly get sucked into the void. Either or. Let's talk about it. In 2023, the James Webb Telescope was used by astronomers to observe starlight from two early galaxies, one of which they believed to be the place where the very first supermassive black hole emerged from. Because of the distance and the speed at which light travels, astronomers were able to view snapshots of the galaxy that show what it would have looked like when the universe was younger than just 1 billion years old. For reference, today the universe is estimated to be 13.7 billion years old. Now, you might find yourself wondering how this is at all scary, considering the fact that the images taken depict something that existed over 13 billion years ago. Well, I'll tell you why it's scary, because it illustrates the way in which, over time, black holes gain unfathomable masses by sucking planets and galaxies into their dull, lifeless voids. Just think about that as you fall asleep tonight. Just last year, the James Webb Telescope picked up strange signals coming from distant rogue planets, which are planets that don't orbit stars. Astronomers have discovered that a pair of these planets, called jumbos or Jupiter-mass binary objects, are emitting mysterious radio signals that are rarely seen from other worlds. Luis Rodriguez and his team used data from the U.S. National Radio Astronomy Observatory to find radio signals from the Orion Nebula and identified one pair, Jumbo 24, emitting steady and strong radio waves. And they're still not exactly sure what is causing these mysterious signals. Next up, forget the dark night, because just 2 years ago, in 2022, the James Webb Telescope just so happened to have possibly discovered dark stars, which in my opinion are way cooler. DC fans, please don't come for me. Anyways, in July of last year, 2023, astronomers released a report saying that what they originally believed to be galaxies might actually be something called dark stars. What are dark stars, you ask? Well, they're super bright stars, ironically, that produce enough light to compete with an entire galaxy of stars. Oh, and they are believed to be powered by dark matter, which is believed to be made up of substances originating from black holes. Cool, cool, cool. While this is pretty freaky, if scientists and astronomers are able to prove the existence of dark stars, they might just be able to rationalize how an incredibly young universe became host to so many large galaxies, just like the ones observed by the James Webb Telescope. Good old JWST. More cool news came out just a few days back about a couple of stars throwing space tantrums. Astronomers using the James Webb Space Telescope made an exciting discovery. A distant star previously thought to be a single protostar is actually a pair of baby stars. And this next part is pretty cool but kind of cosmically horrifying. The young stars are shooting out these insane energy jets as they grow, gobbling up gas and dust from their surroundings. The stars are about 400 light-years from Earth, so luckily, nothing for us to worry about. We can just sit back and watch them freak out with the comfort of being a very safe distance away. Scientists have been studying this system for about 50 years, though they had identified a baby star named WL20S, which is surrounded by a large ring of gas and dust known as a protoplanetary disk. But the James Webb confirmed that it's not one, but two baby stars. Actually a pair of stars, and also revealed the presence of stellar jets, which are superheated material ejected by the star's magnetic poles. Mary Barsany, an astronomer with the Search for Extraterrestrial Intelligence or SEI, said, "What we discovered was absolutely wild. We actually saw that this one star was two stars right next to each other. The two stars are binary stars, meaning they orbit each other. They probably formed from a single protoplanetary disk that split early on. The disks around the stars are about 100 times wider than the distance between the Sun and Earth, and researchers estimate the stars are between 2 and 4 million years old, which sounds very old, but by space standards, it's really not. That's just a tiny fraction of our sun's age. There's also a good chance that planets will eventually form from the leftover material in these disks. Sadly, we'll probably never actually see them though. Next up, inconsistent expansion, the possible end of cosmology as we know it and the reason cosmologists are beginning to believe that our entire understanding of the universe is detrimentally flawed. Rough day to be a cosmos dude. The issue was discovered last year when cosmologists realized that, depending on where they looked, the universe was expanding at vastly different rates, which makes no sense. The phenomenon has been given the name Hubble tension, as it was the 2019 measurements taken by the Hubble Space Telescope combined with the 2023 measurements taken by the James Webb that brought the issue to light. And no, it's not a measurement error, they triple-checked. What it is a significant lack in understanding regarding the universe. In response to the conundrum, the lead study officer and professor of physics and astronomy at Johns Hopkins University said, with measurement errors negated, what remains is the real and exciting possibility we have misunderstood the universe. Guess they're going back to the drawing board. And finally, we have a hellish exoplanet observed by the James Webb Telescope called VHS 1256b. The planet sounds like a description of some abysmal realm in a horror novel. The weather on this planet is downright terrifying, with clouds swirling with sizzling gritty flecks of sand, temperatures hitting 1,500 degrees Fahrenheit, constant brutal sandstorms, and when the clouds get too heavy, they probably dump sand-filled rain on the surface. Scientists recently used the James Webb to study this exoplanet and, aside from the extreme climate, they did spot some familiar elements in its atmosphere. There's water, methane, carbon monoxide, and carbon dioxide. The days are also almost as long as Earth's, only 2 hours shorter. Discovering water and methane is pretty exciting because this means there could be life on Earth. Water and methane are linked to biological activity. If you need help, hang up and then dial your operator. So, the James Webb Telescope only just launched at the tail end of 2021, but it's already made some insane discoveries that have changed the way astronomers think about space. We're still in the very early stages, so there's no telling what this telescope will pick up in the very near future. But here are just some of the scariest, most mysterious, and interesting findings so far. We're starting off the list with the discovery of unbelievable galaxies. These galaxies are nearly the size of the Milky Way, which scientists weren't expecting to see. So why is this? In these deep-field images from the telescope, huge galaxies were observed filled with mature red stars. They look like tiny reddish dots to the powerful telescope, and they came about at the beginning of time, about 500 to 700 million years after the Big Bang. So astronomers anticipated seeing young and small galaxies in the early universe, but the James Webb observations revealed massive galaxies with old red stars, very different from what they'd expected to see and very different from what the predecessor, the Hubble Space Telescope, observed. Joe Leah, an astronomy and astrophysics assistant professor at Penn State, explained that the galaxies appeared 50 times more massive than expected, with some reaching the mass of our Milky Way when the universe was only 3% of its current age. Next up, we have the discovery of jumbos. In 2023, the James Webb Space Telescope discovered over 500 rogue planets, meaning they don't orbit a star in the Orion Nebula. Now researchers have detected mysterious radio signals from a pair of these rogue planets. These planets are known as Jupiter Mass Binary Objects, or jumbos, which I'm going to call for the duration of this point. James Webb, with its ability to pick up infrared radiation, revealed that about 80 of these rogue planets exist in pairs, dancing around each other at distances ranging from 25 to 400 times the distance from Earth to the Sun. Scientists don't really know what to make of these things right now. In fact, they're not even sure if jumbos are planets or entirely new entities, larger than planets but smaller than brown dwarfs. So this is already strange, but it's going to bring us to our next mystery, and that is the mysterious radio signals these jumbos were giving off. So, in order to understand these strange objects, researchers wanted to see if they emitted radio waves, as different cosmic objects produce unique radio emissions. They looked through archives of observations made by the U.S. National Radio Astronomy Observatory and found that one pair, Jumbo 24, did emit radio waves. This Jumbo pair is the heaviest and has the closest spacing between its two planets. The data showed that the radio waves from Jumbo 24 were steady and strong, with a power equivalent to 1/4 of a ton of TNT and frequencies of 6 to 8 GHz. But there was something very strange going on. The signals lacked circular polarization, which is the presence of magnetic fields, which you typically have with planets. The radio signals from Jumbo 24 were a bit unusual. They didn't match the patterns you'd normally expect from planets, brown dwarfs, or pulsars. The researchers considered the possibility of signals coming from an object behind Jumbo 24 but said that was highly unlikely. So they're doing more research into this, but as of right now, it's still a complete mystery. One of the biggest questions everyone has on their mind about space is, of course, is there life out there other than our own? It's one of the main reasons we want to explore it so badly, after all. Well, with the discovery of a very interesting planet called K2-18b, we may have come closer than ever to answering that very question. The telescope found certain molecules in this planet's atmosphere that could indicate conditions suitable for life. K2-18b is an exoplanet located in the constellation Leo, about 120 light-years away from our solar system. It was discovered in 2019, and ever since, astronomers have been pretty excited about it because of the signs of water vapor in its atmosphere. So this planet was always going to be a point of focus for James Webb. The telescope detected carbon-bearing molecules like methane and carbon dioxide in the planet's atmosphere. This means K2-18b may have a hydrogen-rich atmosphere and a surface covered by water, meaning there could very well be life. One of the coolest things the telescope spotted was a molecule called dimethyl sulfide, or DMS. On Earth, DMS is produced by life, specifically by microscopic organisms like phytoplankton. Now scientists aren't 100% sure if they really detected DMS in the planet's atmosphere, but there's a chance, and that's pretty cool if it turns out to be the case. Next, let's talk about a terrifying planet that the James Webb Telescope spotted in 2023, VHS 1256b. This planet seems like Tatooine from Star Wars or Arrakis from Dune, except far worse. If you think sand is the worst and just gets everywhere, try living on VHS 1256b. This planet seems like absolute hell, caught in a never-ending sandstorm. But there are signs it has some similarities to Earth. The atmosphere shows signs of water, methane, carbon monoxide, and carbon dioxide, so there's a chance it could also host life. But aliens that live in a perpetual blistering hot sandstorm may not be the types of creatures we'd want to meet. Seems like they'd probably be a little frustrated. There's that classic saying, the more you know, the less you know. Well, if the James Webb Telescope has proven anything, it's how true that saying really is. It's now found discrepancies with how scientists used to measure the Hubble constant. So first of all, what is the Hubble constant? This refers to how fast galaxies are moving away from us. Imagine the universe as a balloon that's just constantly expanding, and the Hubble constant is the rate at which the balloon is getting bigger. The faster the galaxies are moving away, the higher the Hubble constant. It helps astronomers understand the age and future of the universe, but the rate at which the universe is expanding has never been 100% solved. So scientists figured the James Webb Telescope would be able to shine some light on it, but apparently, it revealed more questions than answers. Most models suggest the Hubble constant should be around 68 km per second per megaparsec. 1 megaparsec is about 3.26 million light-years, not something I can really wrap my head around because I, and likely you, don't really have any relatable reference for that. But the point is, some experts are now calculating the constant to be 69.8 km per second per megaparsec, others are giving even higher values. So there are questions about the accuracy of our measurements and definitely some gaps in our understanding of the universe. Next up, we have dust. Apparently, this stuff is inescapable and has been around a lot longer than we once thought. And if that's not scary, I don't know what else is. Scientists using the James Webb peered into the past and found carbon dust in 10 different galaxies that existed just 1 billion years after the Big Bang. Now this may not seem all that crazy, but this is actually kind of a big deal. You see, what scientists have always thought is that heavy elements like carbon were created in the hearts of stars. When these stars exploded, they scattered these elements as interstellar dust. Then new stars formed from this dust, making galaxies richer in heavy elements. But the JWST found this carbon dust in galaxies that are only about 10 million years old. That's way faster than their previous theories predicted for the buildup of heavy elements in galaxies. So the question is, how did these young galaxies get so rich in carbon so quickly? Almost every large galaxy has one thing in common, a supermassive black hole at the center. But what came first, the black hole or the galaxy? Well, scientists once thought supermassive black holes only showed up later in the universe's timeline, after the first stars and galaxies formed. But surprise, the JWST data hints that these colossal black holes might have been around during the first 50 million years after the Big Bang. In the grand scheme of things, that's very, very early, basically the dawn of time. The team leader Joseph Silk explained that these early black holes could have acted like building blocks or seeds for the galaxies we see today. Instead of forming after the stars, they might have been there from the beginning, influencing star formation. The plot thickens, and black holes were already incredibly mysterious before. We really got to remind ourselves how incredible this planet is. Everything is set up perfectly for life to grow and flourish, unlike 55 Cancri e, which has sent out mysterious signals for almost 2 decades. But the mystery of these signals may have been solved. This rocky world was discovered in 2004. It's around 8 times the size of Earth and is about 40 light-years away. The exoplanet's been emitting strange signals for almost 2 decades. A recent study suggests that volcanoes on 55 Cancri e might be causing these signals. Periodically, these volcanoes open up and spew out hot gas, forming a temporary atmosphere around the planet. But the extreme heat near its parent star causes this atmosphere to burn off, leaving the planet exposed again until the next outburst. The mystery is the signals observed when the planet moves in front of or behind its parent star, creating a sort of eclipse. Sometimes, when it goes behind the star, there's no visible light coming from the planet. Other times, a strong visible light signal is emitted. This is because the planet's proximity to its star triggers outgassing. Giant volcanoes and thermal vents open up, releasing hot carbon-rich elements into the atmosphere. The problem is the planet can't hang on to this atmosphere for long because of the intense heat. It gets blown away, leaving the planet bare until the next outgassing event. So sometimes the planet has an atmosphere, and other times it doesn't, which is pretty odd. Finally, we have the discovery of the oldest known supermassive black hole in the universe. This black hole is luckily extremely far away, 13.2 billion light-years away from Earth, to be exact. This also means we're observing it as it was about 470 million years after the Big Bang. I still find it nuts how these telescopes are basically looking back in time. This black hole is in a galaxy named Z1, and this black hole is believed to be born massive, with an estimated mass between 10 and 100 million times our Sun. The discovery of this thing has astronomers wondering even more about how supermassive black holes form. Did they emerge from the collapse of massive gas clouds or from explosions of the first stars? Well, apparently, this one was massive from the start, meaning it could have formed differently than how other black holes are thought to form, slowly growing and expanding over time as they consume more matter. This one could have had a head start, expanding much faster than what the modeling used to suggest. So basically, that is to say, from every point on this list, we just don't know really what's going on up there in space. And that's kind of the fear of the unknown. It's like the biggest fear humans can have, right? Starting off this list in our number 10 spot, we have time travel. The first large-scale image to be publicly released that was taken by the James Webb Telescope was a mega deep-sky image of a galaxy cluster called SMACS 0723, which sits over 5 billion light-years away from us. The reason this cluster is so profound is that it offers us a glimpse into the early universe. This cluster, despite only being a couple of 100 million light-years across, which in the cosmos really isn't a large space at all, is still the home to thousands of galaxies. But if you look even closer at the image, you can see even more. In between these galaxies are twisting and arcing bands of light, which are even more distant galaxies, but their light is being distorted as it passes through this dense cluster of galaxies. Some of these galaxies are the oldest ever observed, some over 13 billion years old, and this is important because we don't yet know fully how galaxies formed in the early days of the universe. And James Webb is helping us put those puzzle pieces together. In our number 9 spot today, we have the complex galaxies. And with these distant galaxies comes a realization about their structures. Some of these galaxies are far more complex than astronomers had once expected. In a study into the deep field image, researchers found a surprisingly high number of distant galaxies that are shaped like disks. Basically, while using Hubble, scientists believed or had a theory that early galaxies were often more distorted by their interactions with neighboring galaxies, and that these distant galaxies were more irregularly shaped than ones nearby, which, not unlike the Milky Way, are normally more regularly formed in the shape of disks. This changed, though, with the Webb observations, because this telescope revealed that there are up to 10 times as many distant disk-shaped galaxies than what was previously thought. According to some experts, because this contradicts what was once thought about the evolution of galaxies, much more research needs to be put into this specifically to figure out exactly what this means and how it changes our theories moving forward. In our number 8 spot today, we have cosmic noon. Moving on a little later into galactic evolution, one study into Webb's observations focused on cosmic noon, which was a period approximately 3 billion years after the Big Bang. It is an important period because this is the time when star formation peaked in the universe and the most light was created. An astronomer at the University of California, Santa Cruz, named Ran Soos examined images taken by both Hubble and Webb of galaxies at cosmic noon. This is when Ran realized something. The infrared wavelengths detected by Webb showed that the massive galaxies looked significantly smaller than they did in the Hubble images. Of this discovery, Soos said, "It potentially changes our whole view of how galaxy sizes evolve over time." Based on Hubble images, it was thought or suggested that galaxies start out small and grow larger over time. But these Webb images are showing that maybe this isn't the case and that things might be a little more complicated than anticipated. In our number 7 spot today, we have the exoplanet atmosphere. While there are many tasks that the James Webb will be taking on through its career, one of them is to study alien exoplanets, most especially to figure out what their atmospheres are made of. To do this, when the exoplanet passes in front of its parent star, the light from the star, of course, passes through the planet's atmosphere before continuing on its journey. Whatever the atmosphere is made up of, whatever the elements are, it changes the nature of the light, and this is something that James Webb can pick up on. WASP 96b is an exoplanet that we've had our eye on for a while now. It is a giant, gassy planet that orbits close to its parent star, and now it is being used to test Webb's abilities before moving on to more challenging targets, such as Earth-like planets that orbit Sun-like stars. There are a few incredible discoveries that Webb has made in doing this, like the first detection in an exoplanet atmosphere of sulfur dioxide, and new readings are even revealing signs of active chemistry within the atmosphere. This is all to say that these tests are yielding incredible results, which is extremely promising when it comes to the future and the understanding of exoplanets. In our number 6 spot today, we have star formation. People who are busy studying galactic chemistry have been receiving some more complicated and interesting data from Webb. One analysis examined light emitted by galaxies that had a redshift of 5 or greater. In this analysis, they found a surprising richness in elements like oxygen. This is important because astronomers had thought that the process of chemical enrichment, which is the process where stars fuse hydrogen and helium in order to form heavier elements, took a while. But this analysis made them realize that it is happening in earlier galaxies. This has led experts to say that they really need to start rethinking the speed at which we believe star formation occurs. In our number 5 spot today, we have the star life cycle. Speaking of star formation, Webb is showing us both the birth as well as the death of stars. Images produced by Webb of both the Carina Nebula as well as the Southern Ring Nebula are incredible. The Carina Nebula is a star nursery, it is the birthplace of new stars, and the powerful Webb instruments are able to pierce through the gas clouds and show us unbelievable moments in these stars' creations. On the other end is the Southern Ring Nebula, which is produced by a star not unlike the Sun shortly after its demise. By being able to study these different star life stages, we can piece together more about the stories of these stars themselves. In our number 4 spot today, we have Starlight. Back in September of this year, 2022, the James Webb Space Telescope spotted a set of concentric angular rings around a giant but distant star. Of course, we needed to know more, so researchers dove further into the images and found something incredible. A study revealed that these ripples turned out to be puffs of organic dust that were created and then spread across the universe by an odd star system. This might just seem like a cool space occurrence, but this marked the first time researchers were able to find evidence of starlight moving visible matter beyond our solar system, which is absolutely incredible. I mentioned how this star system is odd, and that is because it is made up of 2 stars that orbit each other. In our number 3 spot today, we have Stephan's Quintet. You may be familiar with this term because it was another one of the first photos publicly released from the James Webb Telescope, but it's possible that maybe you didn't know exactly what you were looking at. Stephan's Quintet is a visual group of 5 galaxies, 4 of which form the first compact galaxy group ever discovered. These 4 galaxies will all likely eventually merge with each other, but until that happens, we have these stunning visuals of them all dancing together. Space telescopes like James Webb have provided some insights into some emissions coming from between the galaxy group. It is now believed to be shockwaves in the intergalactic gas, which is caused by one galaxy falling into the center of the group at roughly the speed of several million kilometers per hour. You know, just space stuff. In our number 2 spot today, we have the DART mission. So I'm sure we all remember earlier this year when NASA's DART mission slammed into an asteroid just to see if we could potentially redirect an asteroid in the future if it were on a collision course with Earth. They tested this planetary defense mechanism, and it actually seems to have been largely successful. Among those watching was none other than the James Webb Telescope. Since the mission, information that Webb collected has been sent back to us on Earth, and it is giving us more insight into how to ensure we are using this technology to our advantage and to see how we can improve it. In our number 1 spot today, we have the cloud discoveries. Speaking of exoplanets, James Webb has observed one that has evidence of silicate-rich clouds. Well, it's actually a brown dwarf that is about 20 times the size of Jupiter. It is called VHS 1256b, and it orbits 2 small red dwarfs and is 72 light-years away from Earth. Webb has also used its skills to reveal details in a gas cloud called Doradus 30, which received the nickname Tarantula due to its very spooky appearance. This Tarantula Nebula is located about 161,000 light-years away and resides in the Large Magellanic Cloud. I mean, aside from our very own Milky Way, it is the brightest star-forming region in our neck of the cosmic woods.